Hello, in this lecture we'll find out the area of a square. In the drawing we have a right triangle ABC is a right triangle, and inside this right triangle ABC we have square DEFG. And our mission is to find out the area of this square DEFG. In addition, we know that side AB of the right triangle ABC equals to 5 units in its length, side BC equals to 12 units in its length, and this is angle ABC, that is a right angle. It is equal to 90 degrees in its size. Again, our mission is to find out the area of this square DEFG. So, first of all, we find out the length of the hypotenuse AC by implementing the Pythagoras theorem on this right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, in the right triangle ABC, the hypotenuse is AC, and therefore the square of the hypotenuse is AC squared, and it must be equal to AB squared plus BC squared. So, I repeat again. According to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared, that is the square of the hypotenuse, equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. In conclusion, we found out that AC squared equals to 25 plus 144 is 169. AC squared equals to 169. We will take a root out of this equation, and we get that AC equals to the square root of 169, that is 13. In conclusion, we found out that the length of the hypotenuse AC is 13. So here, I write it down. AC equals to 13 units in its length. In the next step, we'll define this angle ACB as alpha, and we focus on this right triangle ABC. In the right triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Therefore, the missing angle here must be equal to 90 degrees minus alpha. And we define that 90 degrees minus alpha equals to beta. And therefore, the missing angle here equals to beta. We also have the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. Repeat again, the sum of the angles on one side of a straight line is equals to 180 degrees. So, line segment AC is one side of this right triangle ABC, therefore it is absolutely a straight line. So if we focus on the lower side of this straight line AC at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D here? We have this angle that is a right angle plus the missing angle. In total, they must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the lower side of the straight line AC at point D to 180 degrees, the missing angle must be equal to 90 degrees in its size. Likewise, if we focus on the lower side of the straight line AC at point E here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So, which angles we have at the lower side of AC at point E? We have this angle that is a right angle, it is equal to 90 degrees. The right angle plus the missing angle here, in total they must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. So, in the right triangle GEC, in this right triangle GEC, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, and therefore the missing angle must be equal to beta. Here we have the equation 90 degrees minus alpha equals to beta. If we add to this equation alpha and then we subtract beta, we get that 90 degrees minus beta equals to alpha. Okay. In the next step, we'll focus on this small right triangle, triangle ADF. In the small right triangle, triangle ADF, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, yeah? Therefore the missing angle equals to alpha. Okay. In the next step, we'll focus on the upper side of the straight line BC at point G. BC is absolutely straight line because it is one side of the right triangle ABC. Therefore it is a straight line. So if we focus on the upper side of the straight line BC at point G, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of BC at point G? We have this angle that is beta plus this angle that is equal to 90 degrees in its size plus this missing angle. In total the sum of those three angles, 1, 2, 3, in total the sum of those three angles must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. This is the sum of the angles in any triangle. Therefore the missing angle here must be equal to 90 degrees minus beta. Again, 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles on the upper side of the straight line BC. Okay. Therefore, the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle must be equal to alpha. In the right triangle FBG, in this right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Therefore, the missing angle here equals to beta. So in the drawing we have in total 4 right triangles. 1, 2, 3, and the right big triangle, triangle ABC. In those all 4 right triangles, all the 3 angles are alpha, beta, 90 degrees. Okay. In each right triangle, out of those 4 right triangles, the three angles in each right triangle are alpha, beta, and 90 degrees. Therefore, all those 4 right triangles are similar to each other according to angle, similarity rule. I repeat again, all because of the fact that all the angles in those 4 right triangles are correspondingly equal to each other. All those 4 right triangles are similar to each other according to angle, similarity rule. So, for example, but before, okay, so all the 4 right triangles are similar to each other according to angle, similarity rule, because they have the same angles. So, in the next step, we define the length of side BG of the right triangle FBG as x. What is the length of line segment GC? From the drawing, it is very easy to see that GC equals to BC minus GC. Again, BC minus BG equals to GC. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus GC, that is x. In total, GC equals to 12 minus x. GC equals to 12 minus x units in its length. In the next step, we define the length of one side of this square DEFG as L. So DE equals to L units in its length according to our definition, and therefore all the other 3 sides of this square DEFG will be also equal to L. So DF equals to L. Side FG of this square also equals to L, and finally side EG of this square DEFG also equals to L units in its length. So, because of the fact that all the 4 right triangles in this drawing are similar to each other, the big right triangle ABC is similar to the small right triangle FBG. So I write it down. The big right triangle ABC is similar to this small right triangle FBG. Repeat again. Triangle ABC is similar to triangle FBG according to angle similarity rule. And from the fact that those 2 right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side BG over side FG in the right triangle FBG is equals to side BC over side AC in the right big triangle ABC. I repeat again, from the fact that the right big triangle ABC is similar to the right small triangle FBG, we will derive that BG over FG equals to BC over AC. So BG equals to X over FG. FG equals to L, and it is equals to BC. BC equals to 12 over AC. The length of the opposite AC is 13. In conclusion, we found out that according to equation 1, X over L equals to 12 over 13. So here we will multiply this equation 1 by L, and we'll get that according to equation 1, X equals to 12 over 13 times L. Okay, according to equation 1, x equals to 12 over 13 times L. Likewise, we know that the big right triangle ABC is similar to this right triangle, triangle AGC. Repeat again, we know that the big right triangle ABC is similar, this is the sign of similar, to the right triangle, triangle AGC. And for the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that EG over GC in the right triangle EGC equals to AB over AC in the right triangle, triangle ABC. Repeat again, we derive that EG over GC equals to AB over AC. EG is L over GC, GC is 12 minus X, and it is equals to AB, AB is 5 over AC, AC is 13. So in conclusion, found out that according to equation 2, L over 12 minus X equals to 5 over 13. Here we cross multiply this equation, equation 2, and we get that according to equation 2, 5 times 12 minus X equals to 13L. Here we will open the brackets on this side of this equation, equation 2, and we get that according to equation 2, 5 times 12 is 60, 5 times minus x is minus 5x, and it is equals to 13L. Here we add 5x to this equation, equation 2, and we get that according to this equation, equation 2, 5x plus 13L equals to 60. Repeat again, according to equation 2, we actually found out that x plus 13L equals to 60. Here we'll subtract 13L from this equation, equation 2, and we get that according to this equation, equation 2, 5x equals to 60 minus 13L. In this equation, equation 2, we can substitute this x by the value that we found for x in this equation, equation 1. According to equation 1, x equals to 12L over 13. Therefore, we can substitute x in this equation, equation 2, by 12L over 13. We do it now, and we get that according to equation 2, we have 5 times x, and x according to equation 1 is equals to 12L over 13, and it is equals to, according to the equation, equation 2, it is equals to 60 minus 13L. Here we have 5 times 12L is 60L over 13, that is equals to 60 minus 13L. Here we'll multiply this equation, equation 2 by 13, And finally we get that according to equation 2, 60L equals to 13 times 60 is 780, and minus 13L times 13 is minus 169L. In conclusion, we found out that 60L equals to 780 minus 169L. So here we will add 169L to this equation 2. And we get that according to this equation 2, 169L plus 60L equals to 229L, and it is equals to 780. So here we divide this equation 2 by 229, and we get that according to this equation 2, L equals to 780 over 229. So 780 over 229 equals to 3.40611. So actually found out that the length of one side of this square DEFG, the length L, is equal to 3.40611 units. What is the area of this square DEFG? The area of any square equals to the length of one side squared. The length of one side is L, therefore the area will be L squared. So the area of square DEFG will be equal to L squared. And L is 3.40611, therefore L squared is 3.40611 square, and 3.40611 square is equals to 11.6016 square units. In conclusion, we found out that the area of square DEFG is equals to 11.6016 square units. And that is the answer to the question. I repeat again, the area of this square DEFG is equals to 11.6016 square units. So in the next step I will summarize the lecture. So in this lecture we found out the area of this square DEFG. So in the drawing we have a right triangle. Inside this right triangle we have this square DEFG, and our mission is to find out the area of this square. In addition, you know that side AB equals to 5 units in its length, side BC equals to 12 units in its length, and this angle ABC is a right angle. Again, our mission is to find out the area of this square DEFG. So first of all, we implemented the Pythagoras theorem on this right triangle the ABC. So in the right triangle ABC, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and AC squared must be equal to AB squared plus BC squared. Repeat again, in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared, that is the square of the hypotenuse, equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So in conclusion, found out that AC squared equals to 25 plus 144, 25 plus 144 is 169. So found out that AC squared equals to 169, we took root out of this equation and finally found out that AC equals to 13, AC equals to the square root of 169, that is 13. So the length of this hypotenuse AC is 13 units. In the next step, I presented to you the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Line segment AC is one side of this triangle ABC, the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the lower side of the straight line AC at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is equal to 90 degrees, it is the right angle, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. Likewise, if you focus on the lower side of the straight line AC at point E, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point E? We have this angle that is the right angle plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. Okay. In the next step, we defined the length of line segment BG as x, and therefore GC must be equal to BC minus BG. Again, BC minus BG equals to GC, therefore GC equals to BC, that is 12, minus BG, that is x. So in total, BC equals to 12 minus x. And we also defined the length of one side of this square, DEFG as L. So the length of the other three sides must be also equal to L because of the fact that all the sides of any square are equal to each other in their lengths. So all the three sides of this square DEFG must be equal to L. And then we focused on this right triangle, triangle A. Actually, we defined this angle as alpha. So, and we focus on the right big triangle, triangle ABC. In the right big triangle, triangle ABC, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus alpha, but 90 degrees minus alpha equals to beta, and therefore, again, here alpha plus 90 degrees plus the missing angle must be equal to 180 degrees. So the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees in total is 180 degrees, that is the sum of the angles in any triangle. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle must be equal to beta. Then, in this right small triangle AFD, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle must be equal to alpha. Then, in the right triangle EGC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha, but 90 degrees minus alpha equals to beta, therefore the missing angle must be equal to beta. Then BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the upper side of this straight line BC at point G, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of BC at point G? We have this angle that is beta, this angle that is 90 degrees, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Therefore, the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here must be equal to alpha. So in the right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here must be equal to beta. So on those all four right triangles that we have in the drawing, we have 1, 2, 3, and the big right triangle ABC. In total we have 4 right triangles, and all the angles in all those 3 right triangles are corresponding equal to each other. Each right triangle has 3 angles that are alpha, beta, and 90 degrees. And therefore, all those 4 right triangles that we have in the drawing are similar to each other according to angle similarity rule. For example, the right small triangle FBG is similar to the right big triangle ABC according to angle similarity rule. Why? Because those 2 right triangles have the same angles, alpha, beta, and 90 degrees. So the right big triangle ABC is similar to the right small triangle FBG according to angle similarity rule, and therefore the following relationship exists between their sides. Side BG over side FG in the right triangle ABC equals to side BC over side AC in the right triangle ABC. Repeat again. BG over FG equals to BC over AC. BG is X, FG is L, BC is 12, and AC is 13. In conclusion, found out that X, according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by L, and finally found out that X equals to 12 over 13 times L. Likewise, we know that the right big triangle ABC is similar to the right triangle AGC, according to angle similarity rule. And for the fact that those 2 right triangles are similar to each other, we will derive that EG over GC in the right triangle EGC equals to AB over AC in the right triangle ABC. I repeat again, we derive that EG over GC equals to AB over AC. EG is L, GC is 12 minus X, AB is 5, and AC is 13. In conclusion, found out that according to equation 2, L over 12 minus X equals to 5 over 13. Here we cross multiply this equation 2, and found out that 5 times 12 minus X equals to 13L. Here we open the brackets on this side of this equation 2, and finally found out that 5 times 12 is 16, 5 times minus X is minus 5X, that is equals to 13L. Here we added 5x to this equation 2, and finally found out that according to equation 2, (5x plus 13L equals to 60). Here we subtracted 13L from this equation 2, and finally found out that 5x equals to 60 minus 13L. Here we substitute x in this equation 2 by the value that we found for x in equation 1. According to this equation 1, x equals to 12L over 13, therefore we substitute x in equation 2 by 12L over 13 from this equation 1. So we have here 5x in this equation 2, and x is 12L over 13, that is equals to 60 minus 13L. 5 times 12L is 60L, so in total this expression equals to 60L over 13, and 60L over 13 equals to 60 minus 13L. Here we multiply this equation 2 by 13 and finally found out that 60L equals to 13 times 60 is 780 and minus 13 minus 13L is minus 169L. In conclusion, found out that according to equation 2, 60L equals to 780 minus 169L. So here we added 169L to this equation 2, and finally found out that 60L plus 169L is 229L. That is equal to 780. Here we divided this equation 2 by 229, and finally found out that L equals to 780 over 229. And 780 over 229 is 3.40611. So N equals to 3.40611 units in its length. And we know that the area of any square equals to the length of one side squared. Therefore, the area of this square DEFG will be equal to L squared. The area of square DEFG will be equal to L squared. L is 3.40611, therefore L squared is 3.40611 squared, that is 11.6016 square units. In conclusion, found out that the area of this square DEFG is equal to 11.6016 square units. Okay, thank you very much.